Welcome to the next session on fluid mechanics. In this session, we are going to take up numericals on the topic of surface tension. I hope you have already gone through the concept of surface tension. So you will now be able to solve these numericals. The surface tension of water in contact with air at 20 degrees Celsius is 0.0725 Newton per meter. So it is given that the value of surface tension 0.0725 Newton per meter. The pressure inside the droplet of water P is given as 0.02 Newton per centimeter square greater than the outside pressure. Now it is obvious that the pressure inside the droplet has to be some value more than the atmospheric pressure which is exerted from outside. Otherwise, the droplet will not remain in its shape, it will just get bursted if the pressure reduces inside. Calculate the diameter of the droplet of water. So we need to find the value of D, that is the diameter. Now we have already seen the derivation for droplet. We have also seen for bubbles, so please don't get confused. When I talk about droplet, the formula is P is equal to 4 sigma by D. This is the formula. We have to calculate the value of diameter, I know the value of pressure and sigma. The only thing which we need to convert here is the value of this pressure because it is a Newton per centimeter square and sigma is a Newton per meter. So I need to get them to one single unit system. So I'll get them to the SI system. I'll change this 0.02 into 10 raised to 4 Newton per meter square because we know 1 centimeter is 10 raised to minus 2 meter. When I talk about centimeter square, it is 10 raised to minus 2 raised to 2 meter square. So this becomes 10 raised to minus 4 meter square. Now this 10 raised to minus 4 will be at the bottom because centimeter square is below. When I take that above, it becomes 10 raised to 4. So if I substitute here the value of P and sigma in the calci, I'll get the value of D as 0.00145 meter. This is the value of D. This can also be written in terms of mm as 1.45 mm because 1 meter is 1000 mm. So you just need to multiply this with 1000. So it shifts by 3 decimals and it becomes 1.45 mm. Next numerical, find the surface tension in a soap bubble of 40 mm diameter when the inside pressure is 2.5 Newton per meter square above the atmospheric pressure. Now we are talking about the soap bubble, so be careful about the data being given. If you want, you can also write down the data as a soap bubble because this is what indicates the formula that is being used. So this is also a part of your data. Your diameter given is 40 mm. I'll bring this to meters, so I'll divide by 1000. So this becomes 0.04 meter. Next is the value of P given, that is 2.5 Newton per meter square above atmospheric. Since it is above atmospheric, so the bubble will remain in its shape and it will not burst. So I need to find the value of sigma. Now that's pretty simple. You know the formula of P for soap bubble is 8 sigma by D. I know the value of P, I know the value of D. If I substitute in the calculator, I'll get the value of sigma as 0.0125 Newton per meter. Please be careful with the unit of sigma. Students generally associate sigma with stress, and here they tend to write the unit of sigma as Newton per meter square, which it is not. We are talking about surface tension using the same symbol sigma, but be careful, the unit is Newton per meter. Now we'll take up another numerical. The pressure outside the droplet of water of diameter 0.04 mm is given. So I'll just jot down the data first. We have the diameter as 0.04 mm. Now let's convert this into meter. When I convert this into meter, it will be 0.04 into 10 raised to minus 3 meter. I'm not shifting more 3 decimals because the number of zeros just keep increasing, so it's not required. And the pressure outside is given. So let's mark this as P dash, because when we talk about the pressure inside, we are using the symbol P. So now it is given the pressure outside the droplet, that is atmospheric pressure is given to us. Or you can also use this as P atmospheric, something like this. It's your choice of symbol. So you can write this as 10.32 Newton per centimeter square. This is nothing but 10.32 into 10 raised to 4 Newton per meter square. Calculate the pressure inside the droplet. We need to calculate the value of P. If surface tension is given, I write down the value of sigma as 0.0725 Newton per meter, and I need to find the value of P. Now, you need to first understand that the pressure inside the droplet is in excess of the pressure of the outside. So, we need to calculate here P, which is pressure inside the droplet. Okay, so let's write this as P inside, because the value of pressure inside will be actually the formula which we use, that is excess pressure value plus atmospheric. So this is going to be P formula and it is a droplet. So this will be 4 sigma by D. Here I can solve because I know the value of sigma and D. So this becomes 4 into 0.0725 divided by 0.04 into 10 raised to minus 3. When you substitute, you will get this value as 7250 Newton per meter square. Now, this can also be converted into Newton per centimeter square. I leave the choice to you as to how you want to write the answer. So this will become nothing but 0.725 Newton per centimeter square. So this is the extra pressure inside the droplet above the atmospheric. But it is not only this value. So the P inside is actually this P plus P atmospheric. So this sums up to 0.725 plus 10.32, which turns out to be 11.045 Newton per centimeter square, or this can also be written as 11.045 into 10 raised to 4 Newton per meter square. You can use whichever way you want for expressing. So that's all about the numericals of this topic. I hope you have understood the numericals. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.